Hello, period 7. I'm sick, so not there. Sorry I wasn't there yesterday either. And I know this topic is kind of confusing, these word problems. Hopefully, Mrs. O'Connor's video helped you, but today I'm going to try to explain it to you on this video. So, on 6, 7, and 8, which you were supposed to already have done, I'm just going to show you the answers and kind of explain them, and then I'm going to show you another type of problem. So, on 6, Ed drove 240 miles to Cape Cod, and he went on two different highways. So it was a total distance problem of two different rates. So on I-95, he went 55, and on Route 6, he went 50. It says that he traveled for 4.75 hours, which is his total time. So the two times are X and 4.75 minus X, because they have to add up to 4.75 hours. And then to get the distance, you just multiply rate times time. So distance equals rate times time. So that's how I'm getting these numbers, these expressions, It's just multiplying the rate and the time. Since he traveled a total of 240, I added up the two distance expressions to equal 240. Once you set up the equation, the solving should be easy. It comes out to 0.5 for X, which is how long he was actually on Route I-95. Only a half an hour, and then he was on Route 6 for the rest of the time, which is 4.25 hours. Number 7 was about a bus and a car. This time they went the same distance because one caught up to the other, which means they traveled the same distance. So I set up the rate time distance chart again. The bus's rate is X, and the car's going faster, so it's X plus 15. You could have also done the car as X and the bus as X minus 15. It would come out the same. The bus traveled for 10 hours, and the car was going faster, so even though it went the same distance, it only traveled for 7 hours. I got the distances again by doing distance equals rate times time. That's how I'm getting these expressions, is multiplying these two. Because they went the same distance, I just set them equal. And solve, and they only asked for the car's average speed, and that was 50 because X was 35, and then you add 15. Number 8, two trains starting at the same time from stations that are 396 miles apart meet in 4.5 hours. How far has the faster train traveled when it meets the slower one? So since they're 396 miles apart and then they're meeting, you're doing a total distance. So I set up the rates again, X and X minus 8, because one's slower. The slower one has a slower rate. They both traveled for 4.5 hours, and together their distances weren't the same, but they added up to 396. So again, I'm using distance equals rate times time to set up the equation and adding them together to equal 396. When you solve it, you get 48, but that's X. So to find out how far the faster train traveled, that's the one with the faster rate. So I multiplied 4.5 times X because that was its distance. And I got 216. All right, so I'm going to do one more of those with you, and then I'm going to do two ones about where you're solving for the time. Not solving for the time, but you have to set it up different because they're either total time or equal time. Number 9 was not assigned to you, so I'm just going to do it with you now. So this is about Jeremy and Mackenzie driving on I-95, but Jeremy gets on the highway after Mackenzie, and he's traveling faster, so since he's catching up to her, it's equal distance. So Jeremy went 10 miles an hour faster, so I called his rate X plus 10 and hers X. Jeremy traveled for 7.5 hours when he caught up, but Mackenzie left earlier, so she actually traveled for 9 hours because 7.5 plus 1.5 is 9. Distance equals rate times time. So when you multiply those two columns, you get 7.5x plus 75. For Jeremy's distance and for hers, you get 9x. Since it's equal distance, you just set those equal. When you solve it, you get x equals 50. So that was Mackenzie's rate. And Jeremy's rate was 60 miles an hour. All right, so the next page, page 4, is about total or equal time. So instead of giving you a total or equal distance, these are giving you a total or equal time. So because the formula is distance equals rate times time, but these ones are giving you a time instead of a distance, you're going to actually solve that equation for t, and it would be time equals distance over rate. So when I go to set these up, this one's a jet and a plane. She did part of her trip on a jet and part on a plane. So I'm going to actually do the columns in a different order because if you read the whole question, it says that the total time was 6 hours. Since the question's about a total time, we have to add up their time. So I'm going to do distance, that column, rate, that column, and time is going to be distance over rate. So the jet's distance, it tells you, was 1,600 miles. The plane distance was 500 miles. The jet's rate was 4 times faster, which makes it 4x if the plane's is x. Now the time I'm going to get from time equals distance over rate. So I'm going to put 1,600 over 4x for the jet's time and 500 over x for the plane's time. And we want the total to add up to 6. So my equation is 1,600 over 4x plus 500 over x equals 6. To solve a fractional equation, you can multiply everything by the LCD, which would be 4x, least common denominator, so that we eliminate the denominators. These would cancel, you get 1,600. The x would cancel, you get 2,000. And on the right side, you would get 24x. That adds up to 3,600 equals 24x. Divide by 24. And x comes out to 150, which is the plane's rate. 4 times that is 600, which is the jet's rate. All right, so the rest of this page and the next page are all either equal or total time. So I'm going to do one more with you and then let you guys try a couple on your own. So we'll do number 11. Chris walking 2 miles on a track, but then he's jogging. So we have walking or jogging are the two variables. The total time spent. So it's a total time problem again. Time equals distance over rate. So I'm going to do the first column distance, second column rate, and the last column time. It doesn't really matter what order you put the columns in, but because we're doing time equals distance over rate, I'm putting the distance and rate first. The distance for both is 2 miles, but his rates are different. So he jogs twice as fast. So the walking rate would be x and the jogging rate would be 2x. Since time equals distance over rate, you would do 2 over x for the time and 2 over 2x for the other time. The total time is 1 hour. So it's a pretty simple equation. Both times added together to equal 1. To solve this, you can multiply everything by the LCD to eliminate the denominator. There's other ways to solve it too, but this is how I do it. So you could solve it however you want, as long as you get it right. So 6 equals 2x, which makes x 3, which represents his walking rate, which means he jogged at 6 miles per hour. You can set these up other ways if you want, but it does have to be algebraic. You can't just do like trial and error. So I'm just going to have you guys do 2 problems on page 5. They're also about time. Well, they're really about rate, but you're using the T equals D over R to do it. But for these ones, the ones we just did were both total time, and I think these are both equal time. So, yes, because one traveled, they went to 2 different places, but they traveled for the same amount of time. So these are equal time questions. So why don't you try page 5, numbers 12 and 13. I'll be back on Monday, and hopefully, even though I haven't been there, you'll understand what's been going on. You've done distance equals rate times time in the past, but probably not in a long time. And I know these problems can be confusing. So I'll be back Monday. Have a good weekend.